When you're first practicing naming, referring to this handy helper sheet is very helpful, especially when you're looking at the polyatomic ions. So we're first going to talk about those. Now the polyatomic ions can have relatives. So all you really have to remember is the basic 8 polyatomic ion, the ATE, because everything else adjusts from there. So for example, if we look at BrO3, which is bromate, if it gains an O, we call it the perbromate. It's going to become BrO4, keeps the charge, -1, and it becomes per. And then just the normal name, bromate, per like hyper. I've gone up one. If it goes down one, O, one oxygen, still keeping its charge, it's going to be BrO2, -1, and this becomes a bromite. So the ending becomes ITE. So one less is an ite, one more is a per. So what if I lose 2? So sometimes they write this one as either BrO, -1, or OBr. Often you'll see it written that way, -1. Now what we do is we just have an hypo in front of the bromite. So this one becomes hypobromite. Now, not every polyatomic ion will have all these things that happen to it. So if we take a look at SO4, SO4 only has really one relative, and that is SO3, -2. And so its name, so SO4, is sulfate. So SO3 would be sulfite. Now, notice that I'm not going to fill in. It doesn't have a per. It doesn't have a hypo. Now, let's take a look at the acids. What happens with an acid is when you add a hydrogen enough to balance the polyatomic ion out. And so the number of H's you need is actually the charge of the polyatomic. So, for example, for bromate is -1, so that's how many hydrogens I need. So it's just going to be H. I'm going to put a BrO3. And then to name it, you just take the ending instead of bromate. I kind of have a little saying, if I ate it, it was icky. So a hydrogen plus an 8 will become an ick. So the 8 goes away and it becomes an ick. So bromate becomes bromic. B-R-O-M-I-C. So bromic acid. The same thing would happen. I'll do it down here at the bottom. If I have BrO4, -1, its name is perbromate. How many hydrogens I need? I need 1 because of this -1 charge. So I have 1 hydrogen, and so the 8 becomes an ick. So the name would be perbromic acid. So over here, for the us's, if I have HBrO2 or HOBr, their names are just going to end. The ite becomes an us, and so it just becomes bromous acid, bromous, and hypo. Not hydro, but hypo, because the name of this is hypobromite, so now it becomes hypobromous. Sorry for my chicken scratch. So the same thing over here. Sulfate becomes, well, this adds a little extra syllable, and that's how many hydrogens I need. So H2SO4, H2SO3. So instead of sulfate, it's sulfuric. And this acid, and then this one would be sulfurous acid. Now, what if we don't have a polyatomic ion and we have an acid? So, for example, HCl. Well, an ide anion combined with a hydrogen forms an acid, but it's just considered a binary acid. To name a binary acid, you need the stem, you need a hydro first, the prefix, then the stem, which is like the first syllable of the element of the anion, so hydrochlor, and then you have an ick. So these have a hydro and an ick. So just a plain old "-ide anion, normally just an element from the periodic table, is going to be a hydro then an ick. So H2S, doesn't matter about the 2. The 2's there because S is minus 2. So this is going to be hydro sulfur. Again, that little extra syllable for phosphoric and for sulfuric, there's always this little extra. Um, they're all still acids, so we don't want to forget their last name. So CN is cyanide, so it's still an "-ide anion, even though it is a polyatomic. So it's still named with this hydro-ick thing. So hydro cyanic acid. So working backwards then, pretty easy. Hydro. To me, it just remembers I say hi to my buddy. So who's my buddy? Hydrogen and who? Fluoric. So my buddy must be F. Let's take a little look. F is a -1, so I need one H. So it's just HF. If I look at hydrophosphoric, again, I know I just have H. It's not a polyatomic. So who's my element I'm going to look at? I'm going to look for P. Well, I know P is a -3 charge, so I know I need 3 hydrogens. So this is basically how we name acids and how we get the relatives. If you remember, just looking back again, how we get the relatives for our polyatomic ion. As long as you know this column right here, your 8 column, there's a lot of power. You don't need to memorize all those polyatomic ions. If you can remember the rules and if you can remember who the 8 guy is. Most of them do have a 3. Most of them are 3s, but phosphorus group and sulfates group are going to have a 4.